friends, welcome back to video tutorials. Today we are going to discuss new chapter Polynomial. In earlier classes we have studied about algebraic expressions and their operations like addition, subtractions, multiplications, divisions and few algebraic identities. But in 9th standard we are going to learn about what is polynomial, types of polynomials, zeros of polynomials, factor theorem, remainder theorem, values of polynomial and algebraic identities. So first of all, you should know we are going to discuss about two terms. One is variable, another is constant. You know what are variables? Generally, these variables are denoted by symbols x, y, z, x, y, z, and variables can take any values. The values of variable keep on changing. Whereas on the other hand, constant, so it takes any value. Whereas here, constant are generally denoted by symbols A, B, C, etc. And the numeric value of constants remains same throughout the operation. So it remains same. Now this variable and constants. The combinations of variable and constant connected by fundamental operation. So you will write the definitions. What is algebraic expressions? So algebraic expression is combinations of variable and constant connected by fundamental operations like plus, minus, multiplication, division. So algebraic expression, it is a combination of variables and constant connected by fundamental operation plus, minus, multiplication and division. So variable and constant. So it is a combinations of variable and constants connected by fundamental operations like plus, minus, multiplication or division. Example CDC. See, this is algebraic expressions. There are variables, there are constants, and they are connected by these fundamental operations like addition, subtractions. So that is algebraic expressions. Now question arises, what is a polynomial? So we'll discuss what is a polynomial. So we'll discuss polynomial is an algebraic expressions in which variable involved have non-negative integral power. So first you should know what is polynomial. So polynomial is an algebraic expressions. So polynomial is an algebraic expression in which variables involved has non-negative integral power. So what is the polynomial? So we can say that here it is an algebraic expression in which variable involved as non-negative integral power is called a polynomial. So here what is the most important thing is non-negative integral power. So we have one expression here. Example I can say 2x square minus 3x plus 5. So this is a polynomial algebraic expression. Why it is a polynomial? Because variable x, the power of variable x should be non-negative. It is positive. It should not be negative, and its power should be integer. Do you know what are integers? Integers. See, integers minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, like that. These all are integers. So power should be non-negative integers. So non-negative integers. So this should, or we can say whole number. Power should be whole number. It should not be negative. Non-negative integer. 0 can be the power. So it should be, in short, whole number. So what are the two conditions that is necessary for an algebraic expressions to be a polynomial? So first thing is that the power should be positive, that is it should be non-negative integer. We use the term non-negative, which it should be positive, and integral power, integer it should be. Or we can say whole number, power should be whole number, which we can say here whole number. First condition, what should be? It should be positive, power should be, it should be positive. And second, it should be integer. Integer is fixed value. So here you see variable x, the power of variable x is 2, here the power of variable x is 1, so they are what? They are non-negative and they are integer, so it is a polynomial. Okay, one more examples we can take here, say. What about this algebraic expression? Is it a polynomial? So you have to look at the variable. Here variable is x, power of variable x 3, power of variable y is 2, power of variable x is 1, power of variable y is 1. So all these powers of variables are whole number. Is it clear? So it is a polynomial. Now we can have an example. See here. What do you say about this? So here you see the power of variable x is minus 3. So it is not a polynomial. So this is not a polynomial. This is a polynomial. This is a polynomial. It is not a polynomial. Why? Because the power of variable x is negative. Okay. What do you say here? Is it a polynomial or not? So you look at the power of x. It is not an integer. It is a fraction. It is a decimal. Half. Half means 0.5. So it is not an integer. So this is not a polynomial. So question arises, when you can say a given expression is a polynomial? So given expression is a polynomial when power of variable should be positive and it should be integer. It should not be fraction. Okay. So again we will discuss few problems here. But before that, so which are the two conditions for an algebraic expressions to be a polynomial? The first condition that it should be, power should be positive, power should be positive and power should be integer. It should not be any fraction. Okay, now if I say here, see 3 root x plus 7. So what do you mean root x? Root x means we can write this as 3x raised to half. We have one formula, if you know, nth root of a raised to n is raised to a raised to m upon n. See this n. Okay, nth root of a raised to n, square root of n upon n. So whatever here in this will be in denominator. So n cube of a is to n is to a is to n upon n. So now root x. Root x. So here is root means square root. Here it is 1. So what you will write? X is to 1 upon 2. Whatever here, okay, in this depression, that should be here in denominator. So 3 root x plus 7. So I can write 3x raised to half plus 7. So you look here. What is the power of variable x? The power of variable x is half. It is not an integer. So this is not a variable. Okay, so this is the very important part of your chapter. You should know which algebraic expression is a polynomial. So here polynomial is an algebraic expression in which variable involved. So this is the variable involved. Variable involved has non-negative integral power, or the power of variable should be whole number. So two conditions that is necessary for an algebraic expression to be polynomial is its power should be positive. See here, this is also not a polynomial if I say. See, the power of variable x is minus 7. So it is negative. So the power should be positive and it should be integer. These are the two conditions for a given expressions to be a polynomial. Is it clear, or you want few more examples? See here. Is it a polynomial? Yes. Why? Because sir, here root 3. Okay, root 3. This is not a variable, no. You have to look only variable. So here the power of variable x is 2. This 3 can be written, root 3 can be written this way, 3 raised to 1 by 2. But this 3 is not a variable, it is a constant term. You have to just look at the power of a variable, not any term. So this is a polynomial. This is a polynomial. If I say 7 root x plus 12, is this a polynomial? No. Why? Because here root x, this is a variable. So this can be written as 7x raised to half plus 12. So here variable x has power fraction. So it is not a polynomial. This is a polynomial. This is not a polynomial. Clear? So with this, is it clear that when a given expression, algebraic expression, is a polynomial? You got it? Now we'll discuss polynomial in one variable. So polynomial having single variable is called polynomial in one variable. Okay, see, this is a polynomial in one variable. Polynomial in one variable. So polynomial having one variable. See, the 7x square plus 8x plus 3. This is a polynomial in one variable. Why? Because there is only one variable. I can say 2y cube plus 8y. This is a polynomial in one variable. Why? Because there is only one variable, y. What about this 2x cube plus 5y square minus 7x1? Is this a polynomial in one variable? No. Why? Because there is variable x and there is variable y. So this is not a polynomial in one variable. There are two variables. So this is called polynomial in two variables. So it is a polynomial in two variable. So polynomial in one variable and polynomial in two variable. If there is one variable, we can say it is a polynomial in one variable, and if it has two variables, then we can say it is a polynomial in two variables. See now, we'll discuss few more. Is this a polynomial? See, this x divides each and every term. So we can write this x raised to 4 upon x. So that will be x cube. X square upon x. So that will be x. 3x upon x. So that will be 3. So this is a polynomial. Why? Because the power of variable is positive. See, 3 and 1. So power of variable are whole numbers. So it is a polynomial. Clear? If you want to discuss few more examples, I can say root is 4x minus 3. What do you see? Is it a polynomial? See here, x raised to 5, here it is 2. So I told you one formula, if you know that m root of a raised to n is equals to a raised to n upon m. This is the identity you have to remember. Whatever here in the root will be in denominator. So here what you write? X raised to, here it is square. Square, this is square. No need of writing this square. So what you write? X raised to 5 by 2 is 4x minus 3. So here the power of variable x is a fraction. So this is not a polynomial. Have you got it? So now you will be able to differentiate which algebraic expressions are polynomial and which are not. Now terms and coefficient of a polynomial. Terms and coefficient of polynomial. So we are going to discuss terms and so the part of a polynomial separated by algebraic operation like plus, minus, multiplication and divisions are called terms. See, I will write one. See, this is a polynomial. Why? Because we see variable x, the power of variables are non-negative integers, so it is a polynomial. Now, the part of a polynomial separated by minus and plus. See, so part of a polynomial which is separated by plus, minus, multiplication or division are called terms. So this is one term, this is second term, this is third term. So there are three terms in this polynomial. So what are terms? So term is nothing but it is a part of a polynomial which is separated by symbols plus, minus, multiplication and divisions are called terms. Clear? And now we discuss. And each term of a polynomial has a coefficient. See, you take this term. One term is 2x squared. Here it is minus 4x. Here it is positive 3. These are the terms. So each term of this polynomial has a coefficient which is constant. See, this is coefficient of x squared. It is a constant. This is constant. 2 is constant. Here minus 4 is constant. Here 3 is constant. So they are called coefficient. See this 3, x square, x raised to 1 and I can write here x raised to 0. Why? See here, x raised to 0 is equals to 1. So 3 into x raised to 0 and x raised to 0 is 1. So 3 into 1 is 3. So no need of writing this x raised to 0, just we are writing 3. You got it? See this term 3, I can write 3x raised to 0. X raised to 2, x raised to 1, x raised to 0, x raised to 0 is how much? 1, so 1 into 3 is 3. So we are discussing two things here, terms and coefficients. So what is term? A polynomial is separated. It is a part of a polynomial which is separated by symbol minus and plus are called terms, and each term has a coefficient which is constant. So each term has a coefficient. See, this is coefficient. This is coefficient, this is coefficient, which is constant. So here, these are terms, and if I talk about coefficients, so coefficient of this term is 2, coefficient of this term is minus 4, coefficient of this term is 3. So they are constant. They may be any real number. See, once again we will see one more example. See this here. 3x cube or 3x plus x cube x plus 1 upon x. So this one expression is given here. Okay, this expression is given here, same the everything. Now you want to write terms and coefficients. See, so what you will do, you will multiply this 3x into x. First you will multiply with this, then you will multiply with this 3x into x. 3x square plus 3x into 1 by x, 3x into 1 by x plus x cube into x plus x cube into 1 by x. See, now 3x square plus x cancels, so 3 plus here x raised to 4 plus here x and x cancels, so x square. So these are the terms. So So there are 4 terms in this algebraic expression. Okay, 3x square plus 3 plus x to 4 and x square. If you talk about the coefficient, so coefficient of first term is 3. This is coefficient of second term is 3. Coefficient of third term is 1. Coefficient of fourth term is also 1. Have you got it? So terms and coefficient of a polynomial. Now we'll talk about degree of a polynomial. Very important topic. Degree. Degree of a polynomial. So what do you mean by degree of a polynomial? So the highest power of a polynomial is called degree of a polynomial. So highest power of a variable. Highest power of a variable in a polynomial is called degree of that polynomial. Degree of that polynomial. See example I will say. See. So this is a polynomial. Why? Because see variable x has power 5, 3, 1. All they are whole number, not negative integer. So it is a polynomial. Now you have to find which is the degree of a polynomial. So highest power of a variable. So among this all power, which is the highest power? 5 is the highest power. Here 5 is the highest power. See this 5 is the highest power among all the power. Here it is 1. So highest power of a variable in a polynomial is called degree of that polynomial. So degree of this polynomial is 5. So therefore I can say degree is 5. Clear? One more example you see. See, this is the polynomial. Can you tell me which is the degree of this polynomial? So you have to see the power. Your power is 3, your power is 1, your power is 7. So highest power is 7. So you can say degree is 7. Okay, now if I say here highest power is 3, so degree is 3. So degree is 3. So in short, what is degree of a polynomial? So the highest power of a variable in a polynomial is called degree of that polynomial. So all these are polynomial in one variable. Similarly, we are able to find degree of polynomial in more than one variable. Okay. In that case, actually it is not included in your syllabus, even though we will discuss. Now, degree of polynomial in 2 or more variables. Degree of polynomial in 2 or more variables. So how you will find degree of polynomial in 2 or more variables? So we will take one example here. 7x cubed minus 5 x square y square plus 3xy plus 6y minus 8. See, this is a polynomial in 2 variables. The variable is x and y. Clear? So here how you will find. So here in this case you have to find the in each term. See here the power of variable x is 3. Here there are 2 variables x and y. So you have to add their power. 2 plus 2, 4. Here it is 1 and 1. 1 plus 1, 2. Here it is 1. So sum of the power of variable in each term you have to calculate, and the highest among them is called degree of polynomial. So here in this case, what do you say? What will be the degree? So here I can say degree. See, here it is 3. Here 2 plus 2, 4. So degree is 4. Highest power is 4. So you have to add the power of variable in each term, and highest among them is called degree. So here it is, the degree is 4. So this way you can find degree of polynomial in two or more variable. See now. Here, what will be the degree of polynomial? See here, you add the power. 3 plus 2, 5. 2 plus 2, 4. 1 plus 1, 2. So here degree is 5. Here, so degree of polynomial in one variable and degree of polynomial in two or more variable. So we have learned what is algebraic expression, when a given expression is a polynomial. Then we have learned about the term and coefficients. Then we have talked about degree of polynomial. Now we will discuss types of polynomial. So classification of polynomial, we will see. Classification of polynomial. So now classification based on terms. First we will see classification based on terms. So classification of polynomial based on terms. So I told you what are the terms. So on the basis of number of terms, the polynomial are classified as monomial, binomial and trinomial. So first we will discuss what is monomial. So polynomial containing one non-zero term is called monomial. Okay. So polynomial containing only one non-zero term is called monomial. So what is monomial? So it is a polynomial containing only one non-zero term is called monomial. Example, see monomial, you can say x cube is a monomial. There is only one term. Okay. Then 7x is a monomial. Minus 2 is a monomial. 5 by 2 is a monomial. Why? Because there is only one term. See one thing. If I write 7 is a monomial. So 7 there is no variable. See 7 means I can write x raised to 0. Okay, x raised to 0 is 1, so that is equals to 7 into 1, so that is equals to 7. So just 7 means it is 7x raised to 0, only one term. So polynomial containing only one non-zero term is called monomial. Then comes binomial. So binomial means polynomial containing two non-zero terms. It's called binomial. Example, we can discuss a binomial. See example, we can say x cube plus 2x. This is a binomial. Okay. Then 7x plus 5 is a binomial. X square minus 5 by 2 is a binomial. Or x plus 5 is a binomial. So all these are the polynomial. They are having only two non-zero terms. So they are called binomials. Then comes trinomial. So polynomial containing three non-zero terms. How many? Three non-zero terms are called trinomial. So example, you can discuss trinomial. 2x square minus 5x plus 7 is a trinomial. Or I can say x raised to 5 minus x square plus x. This is also a trinomial. Or I can say here x raised to 7 plus 3x plus 5 by 2. So in short, this is the classification of polynomial based on number of terms. So a polynomial containing only one term is called monomial, two term is called binomial and three term is called trinomial. Now we'll see one more classification. Classification based on degree. Classification based on degree. So now we are going to talk classification based on degree. That's a constant polynomial. So constant polynomial of degree 0. Polynomial of degree 0. Polynomial of degree 0 is called constant polynomial. So what is constant polynomial? It is a polynomial of degree 0 is called constant polynomial, or we can say a polynomial containing only one constant term. See example. 7. This is a constant polynomial. Why? Because 7, I told you, 7 can be written as 7x raised to 0. Why? Because x raised to 0 is 1. 1 into 7, so that is equal to 7 into 1, so that is equal to 7. So this 7 is a constant polynomial. Why? Because its degree is 0. If I write 7, it means 7x raised to 0. Clear? 7 means 7x raised to 0. If I write minus 2, it means minus 2x raised to 0. All these are called constant polynomial. So a polynomial of degree 0 is called constant polynomial. It is a constant. Why? Because there is only just a constant term. Then comes second, linear polynomial. So polynomial of degree 1. Polynomial degree 1 is called linear polynomial. See example, I can say 2x minus 3, 5x plus 7, all this you see. Here you see the power of variable x. Here the highest power of variable is 1. Okay, this I can write now, 2x raised to 1 minus 3x raised to 0. So highest power is 1, so degree is 1. So such polynomial having degree 1 is called linear polynomial. And in linear polynomial there are at most 2 terms. See, at most 2. It is not necessary that there should be 2 terms only. At most 2. At most means vadhuma vadhu be term. Be karta ocha term hoi shake. See, I can take this example also for linear polynomial. Please. It is a linear polynomial. Why? Degree of this polynomial is, the highest power is, if I write 3 raised to x, highest power is 1. So highest power is 1, degree is 1. So it is a linear polynomial, even though it has only one term. It should have at most 2 terms. At most 2 terms. So remember this very important word, at most. At most. It should have at most 2 terms. Maximum 2 terms. Less than 2 terms are viable. Clear? And if we see standard form of this linear polynomial is standard form. Standard form of linear polynomial, I can write ax plus b. A is not equal to 0. See, if I talk here 2x minus 3. See, the coefficient of x is 2. I told you, no, coefficient here, this is called a and this is called b. So general form I have written, see this ax plus b. So here a is equals to 2 and b is equals to minus 3. Here if I talk, a is equals to 5 and b is equals to 7. So a and b are constant and this a should be not equal to 0. Why? Because if a is 0, see I can get 0x plus 7. So 0 into x, 0. So 0 plus 7. So that will be 7. So now it is what? It is a constant polynomial. It is not a linear polynomial. Are you getting what I am telling? So the standard form of linear polynomial is ax plus b. Condition is that this a should not be equal to 0 and a and b are constant. B can be 0. B can be 0. See 3x. I can write this 3x as 3x plus 0. So a is equals to 3 and b is equals to 0. B can be 0 but a should not be 0. Why? Because if a is 0, then 0 into x will be 0 and remaining will be 7 and that will be a constant polynomial. Have you got it? So what is linear polynomial? A polynomial having degree 1 is called linear polynomial. It has at most 2 terms. It may have 1 term also, and standard form is ax plus b, where this a is not equal to 0 and a, b are constant. Now comes third one, quadratic polynomial. Quadratic, the polynomial of degree 2. The polynomial of degree 2 is called quadratic polynomial. Example C, we will see 3x square minus 5x plus 7, or I can write 2y square plus 3y plus 8 by 7. This is polynomial in variable y, this is polynomial in variable x. Both are polynomial in one variable only, but you have to look at the highest power. Highest power is 2, so it is a quadratic polynomial. Again I can take example, see this. There are only how many terms? 2 terms. So it should have at most 3 terms. So we can write at most 3 terms. Vadhu term. At most 3 terms. It may have 2 terms. It may have 1 term also. See, this is also quadratic polynomial. I can say x square. This is a quadratic polynomial. Why? Because highest power is 2. So degree is 2. So degree is 2 means it is a quadratic polynomial. Clear? Now we'll discuss what is the standard form. So standard form is we can say standard form is ax square plus bx plus c, and this should not be 0. See, if this 3 is I write here 0, then 0 into x square will be 0. So what will be left here? 5x plus 7. So that will be now linear polynomial. So it is necessary that this a should not be 0. If it is a 0, a is 0, then it will become linear polynomial. So here a is not equal to 0 and a, b, c are constant and they belong to real number except a. Clear or not? A is not equal to 0. So constant polynomial, polynomial of degree 1, 0 is called constant polynomial. Linear polynomial, polynomial of degree 1 is called linear polynomial. Quadratic polynomial, so polynomial of degree 2 is called quadratic polynomial. Now cubic polynomial. Cubic polynomial. Cubic polynomial. So polynomial of degree 3. Polynomial of degree 3. Degree 3 is called cubic polynomial. Now we'll see the example. So example we can say 2x cubed plus 5x squared minus 7x plus 8. See, the highest power of a polynomial is 3. So degree is 3. So such polynomials are called cubic polynomial. Clear? And it has at most how many terms? So at most 4 terms it has. At most 4 terms. Not necessarily always it should have 4 terms. At most 4 terms. It may have 3 terms, it may have 2 terms, it may have 1 term also. Clear? Vadhu 4 terms. See, I can write this one also. 7x squared minus x cubed plus 8. Highest power is 3. It is having altogether 3 terms. But you have to see which is the highest power. Highest power is 3, so it is a cubic polynomial. At most 4 terms means maximum 4 terms. Okay. Example, I can say this also. Y cube. This is also a cubic polynomial, even though it has 1 term. So standard form we can say now. Standard form. So standard form is ax cubed plus bx squared plus cx plus d. And this leading coefficient here, this is called leading. See, the term with highest power this is the term with highest power, and its coefficient is called leading coefficient. The term with highest power, a coefficient of a term with the highest power is called leading coefficient, and this should not be equal to 0. See, this is 0 here, 2 is 0. If 2 is 0, then 0 into x cube is 0. So this term will be removed. So it will become quadratic polynomial. Why? Because now highest power is 2. So necessary is that this coefficient should not be 0. This is the term with highest power. Its coefficient is called leading coefficient. So now here we can say A is not equal to 0 and A, B, C and D are constant. You got it? So this A, B, C, D are constant. They are real number. Whatever it may be. See here is -1. See here A is 2, B is 5, C is -7 and D is 8. So this is cubic polynomial. Now biquadratic polynomial. Biquadratic polynomial. Biquadratic. So polynomial having degree 4. And degree 4 is called biquadratic polynomial. Example C. Look here. Highest power of a polynomial is 4. So here degree is 4. So this is the term with highest power. And the coefficient of this term is called leading coefficient. It should not be 0. So if it is 0, then what will happen? 0 into x raised to 4. So the whole term will become 0. So now this will be the polynomial. And here the highest power is 3. So it will become cubic polynomial. Have you got it, friends? So standard form, if I say A x raised to 4 plus B x cubed plus C x squared plus D x plus E. This is the standard form of biquadratic polynomial. So here leading coefficient is leading coefficient. So A should not be equal to 0. And A, B, C, D, E are constant. They are constant. And they belongs to real number. It may be natural number, it may be whole number, or it may be integer, or it may be rational number. Here, so this is called. And here at most how many terms it has? 1, 2, 3, 4, 5. So at most 5 terms. Biquadratic polynomial have at most 5 terms. At most 5 terms. Have you got it? So this is the classification of a polynomial based on. We'll discuss one more. So note 0 polynomial you can say. This is not 0 polynomial. See what do you mean by 0 polynomial? A polynomial having only one term and that is 0 is called 0 polynomial. Here, now see. Any polynomial if I say is 0. So what about its degree? Its degree is not defined. Why? You can say, see, we have seen constant polynomial having degree 0. This is called constant polynomial. 0 polynomial means 0. This particular 0 is called 0 polynomial. It has no degree. Its degree is not defined. Why? Because I can write the 0 is equals to 0 into x. I can write the 0 into x squared. I can write 0 into x cubed. See, in all the case, 0 into x is 0. 0 into x squared is 0. 0 into x cubed is 0. Here power is 1. Here power is 2. Here power is 3. But finally the answer is 0. Whatever may be the power. So its degree is not defined. So we can say an important note, degree of 0 polynomial is not defined. I got it? So in short, now if we see types of polynomial based on degree, then first degree 0. degree 0, it is called constant polynomial. Degree 1, it is called linear. Degree 2, it is called quadratic. Degree 3, it is called cubic. Degree 4, it is called biquadratic. Clear? So, based on degree, these are the types of polynomial. And if you want to write standard form, and for your time information, see, if you want to write standard form, the standard form of this, there is no standard form for constant polynomial. No, 7, 8, minus 3, minus 5 by 2. This can be a constant polynomial. So that's no standard form. But here for this linear, standard form is ax plus b and a is not equal to 0. Here it is ax square plus bx plus c. Here a is not equal to 0. Here cubic ax cube plus bx square plus cx plus b. Here also a is not equal to 0. Here biquadratic ax raised to 4 plus bx cube plus cx square plus dx plus e. Here also a is not equal to 0. And in all this case, you know that a, comma b, comma c, comma d, comma e belongs to real number. So this is the moral of the story. I hope you have enjoyed this lecture. So in this lecture we have learned when a given algebraic expression is a polynomial. Then we have talked about terms and coefficients of a polynomial. Then we have talked about degree of a polynomial in one variable, degree of a polynomial in two variables, types of polynomial based on number of terms, that is monomial, binomial, trinomial, and types of polynomial based on degree. Okay, so with this I am going to complete this lecture. I hope you enjoyed this lecture. Just to go through the theory, I am sending one exercise based on this theory. Okay, so please complete that exercise. Thank you very much.